Okay, let's try a couple more transformation of inverse equations or functions. Now, this is kind of nice. I like these ones because we don't have to do 4 points or 5 points or 6 points. We can just do the rule, do a couple of points, and then kind of move on. So let's take a look at, let's do the rule here first because we can take a look at it. And so for the x's, it says +1, so we'll do the opposite. We will -1. For the y's, it says times by 2 and -5. So 2y -5. So that'll be our rule. Now let's actually do this. So step number 1 would be to write down all your points. Done. It's done for you. Step number 2, or in this case our actual very first step, would be to invert them. So you want to switch it, 4 and then -4, right? Because you want to do the inverse. It's asking for f of -1. So that's a hint to you that you need to invert the point first. Once you do that, you can then do your rule. Now our rule is x minus 1, x minus 1 and 2y minus 5. X minus 1, 2y minus 5. So we'll do that. You take the 4, put it into there. 4 minus 1 is 3. And then -4 into there is -8. -8 minus 5 is -13. And that's all there is to it. So step number 1 here is to do your inverse. So we'll swap the x and y. And then step number 2 would be to use the rule. Now the rule is the same, x minus 1, 2y minus 5. So 77 minus 1 is 76. And then 13 doubled is 26 minus 5 is 21. And so that's all there is to those two questions. Now, I want to get to example 4. So how do we find the inverses of functions or relations algebraically? I told you before, I said like, oh, if you have an inverse function of x plus, if you have f of x plus 7, well, the thing that would undo it would be x minus 7. It kind of just, if you add 7, then we'll subtract it. We'll get you back to where you started. It undoes what the function did. So how do we find those when we have things that are a lot more complicated? Like the inverse function here, of x would equal x plus 3. But how do you actually do that? And so to do that, we can go back up to here. So step number 1. What do we have to do to find inverses algebraically? Well, we do what we did for graphing. The very first step was swapping the x and the y. That's our very first step. And then step number 2, we want to isolate the y. Get the y alone. Now, I guess there actually is 2 different ways to do this, or maybe even more, but this is the way that I've done it. First, I swap the x and the y, and then I get the y alone. And you'll see how this works. Now, I know that the function here, the inverse of this, will be x plus 3. It'll undo that, but how to get there? So step number 1, swap the x and the y. So there's x, there's y. Step number 2, get the y alone. So we'll add 3 to both sides. So you have y equals x plus 3. Done. Now I actually like to write, I like to write the y first on this side, but I like to write the inverse of f. I like to write it like that, the inverse notation, and then it's x plus 3. So I just rewrote the y as f inverse of x because you want to indicate to the reader that this is the inverse function, and then it's this x plus 3, so I wrote x plus 3. So that is how we do this. It gets obviously a lot more complicated, but let's do a few more of these easier ones. So you can swap the x and y there. And now you need to work backwards BEDMAS. You need to get this y alone. So first we'll move over the 16 by adding it. So I have x plus 16 is equal to y squared. And we can square root. So then you have y equals. Now you probably forget this, but whenever you square root to cancel a square, you're going to get a plus or minus. So y equals the square root of x plus 16. So if you could think about it here, this says whatever number you choose, square it, and then minus 16. And then what we're saying here is, we'll take that number, add the 16, and then root it. So it undoes it. The last thing we did was minus 16, so the first thing we'll do is we'll add the 16 to undo that, and then we'll square root to get rid of the square. So anyways, we can write this down. This is now isolated. F negative 1 of x is equal to plus or minus the square root of x plus 16. So let's try another one. So make this my x, make this my y. 4 minus 5. So I need to get rid of this 4 first. I can subtract it over. X minus 4 equals negative 5y. If you ever wonder how I solve these things, in case you've forgotten, this is BEDMAS, and you work backwards. So I can see this was a positive 4, that is a plus 4. You don't see the plus, it's a positive 4. And so I need to get rid of that plus 4, this addition, by subtraction. And then I've got a multiply here. So I got rid of this, and then I'll get rid of the multiply. So I'm working right to left. And so I get rid of the multiply by dividing. You got to divide the whole side there. So y is equal to x minus 4 over negative 5. So you write the f negative 1 of x. Now it does look a little nicer if you bring that negative and you throw it in. So I'm going to make it a negative x and a positive 4. I'm going to throw that negative into the numerator. So make it a negative x and a positive 4 all over 5. So you don't need to do that. It's just convention to not have the negative on the bottom. Okay, and lastly, we need to x, y, negative 2y squared plus 8. So I swapped them. So you can think about backwards BEDMAS here. There's this plus 8, this addition. Well, first of all, there's no subtraction happening here. So then there's addition. So I need to get rid of that by minusing 8. So I have x minus 8 equals negative 2y squared. So that's the addition. There is some multiplying. So we'll do the multiplying next by dividing by negative 2. X minus 8 over negative 2 equals y squared. There's no division, but there is an exponent. So now I'll do the exponent. So I'm going to get plus or minus the square root of x minus 8 over negative 2. So how would we write that? Well, I'd write the plus, I'd just rewrite it, f negative 1 of x. And then I would bring this negative up. So I'd make this to the numerator here. I'd make that a negative x and a positive 8. Negative x and a positive 8 all over 2. So there you have it. That's how I solved this using backwards BEDMAS. That should be pretty obvious, but in case you've forgotten, maybe you find that helpful, I don't know. There are more questions to do down below, and they are going to get more complicated. But it's good to get a good understanding, a good base before we move on to those. So I'll do the other ones in the next video. Let's hold on here. Actually, no. Maybe I'll do, because I mean F is actually quite easy. It's E that's the most challenging one. You might want to put a star beside E, but I mean it's not too bad. So yeah, I'll just do this. I thought there was something else, but it's not. So I'll swap those. X equals the square root of y plus 4. And then you're doing backwards BEDMAS. So I can't get rid of, I have to get rid of the square root first. That's kind of like the brackets. You kind of have to get rid of those things first. So even though b is at the very end, I'm going to do that. I'm going to do this first because it's covering over everything else. So I have an x squared equals y plus 4. And then I can just subtract over the 4. And I have x squared minus 4 is equal to y. So that's all there is to it for that one. X squared minus 4 is my inverse function. Now let's take a look at y equals 1 over x plus 3. So I'm going to make that an x, and I'm going to make that a y. Y cubed plus 8. Now, what makes this one more difficult is because there's something on the numerator, but you can just bring this thing up onto this side. So algebraically, what you end up doing is multiplying both sides by y cubed plus 8. Multiply this side by y cubed plus 8. And that, on the numerator and denominator, will cancel. Now, what people want to do is bring this x in. But I'm not going to do that. I'm going to leave it. X equals y cubed plus 8. And on the right side, there's just a 1. And the reason is I want to get rid of this. I want to get the y alone. So why would I want to attach an x? I go x times 8, 8x. And then I go x times y cubed. I would get a y cubed x. And I'm trying to get the y cubed alone. Why would I attach an x to it? So if I keep it separated, then what I can do is I can actually divide it over to the other side. And now that I have no brackets around anything, I can do backwards BEDMAS, where I can just subtract the 8, which looks a little odd. Y cubed equals 1 over x minus the 8. And then to get rid of a cube, you can cube root. Now when you square root, you got to do a plus or minus, but a cube root you do not. Not when it's an odd exponent. Cube root of 1 over x minus 8. And so that is it. My y is a lone. That's my inverse function. So maybe it wasn't as difficult as you had thought. Maybe it is. So just keep that in mind, that we could have ones where there's a denominator here that needs to be dealt with. So what ended up happening? Well, this y cubed plus 8 went up to this side, and the x went back down to here. So basically I swapped them. I brought this up to here, and I brought the x down. And so that's what you see here. The y cubed plus 8 is up, and the x is down. And then you can just move over the 8 and cube root. So I'll zoom out there so you can see E and F. We are done with the inverses. So what we have done so far is we've done what have we done? We have done 2 chapters of transformations, and then we've done absolute values, and we've done inverses with transformations part of that. And so the last 2 chapters are graphing, and they're a little bit different, but you're going to be graphing, and then we're going to be transforming those graphs. Very much like there was that one section that we've done so far where there's a base function. And what's the base function and what are the transformations? And we had to write down the base function and write down all the transformations. Now we're going to be given that base function, and we're actually going to have to draw it. So it's a little bit different, but the transformations are all the same, which is why it's part of that. So we've got that. We got two chapters of that, and then we're done this whole unit.